Hey, what's up, everyone? It's Dr. Glenn Vo. I'm actually back down here in the mad scientist room of Ultradent, right? So I'm here. We're going to do those examples again of the bonding strength, and I'm here with Neil again. So I'm actually going to send this over to Ben. Ben, say hello to everyone, Nifty Thrifty Dennis. So Ben is going to be our camera guy here. All right, Neil, say hello. You're back on camera here. All right, so we are back again, and we did a really cool experiment yesterday. We were testing it with this. What was this called again?
This is called an Instron testing machine.
And we used that to test the bond strength yesterday. We used the Peak bond, and we tested that. And today we have some samples. Yesterday we did an immediate test. We had some samples that we left overnight, and it was stored in this. What do you call this?
This is just a hot water bath, so it's running at body temperature.
This is probably the nicest hot water bath that I've ever seen. So guys, this is going to be like a cooking show. This is like, we cooked this yesterday, we're going to bring it out today. But what we have here is we have this machine here, and we also have, can I go ahead and take one of these out here? What's really cool is that they place these samples in right here. Can you guys see that here? And what material is this again?
This is methacrylate, and then it's a whole human tooth that's been mounted in that.
Now, why is it important whenever you guys do these experiments, these trials? Why is it important to put it in here as opposed to just holding the tooth or maybe just mounting it in stone?
Yeah, so we a long time ago found that we really needed to be having the tooth held in something quite rigid, and that we can section off faces and make this piece that we can hold on to. If you're just holding a tooth, or even if it's mounted in stone, it could crack out and break during the test. So when we're putting it and locking it into this machine, we now have a controllable surface, and we control every detail of that down to the mold size and the rest of that. So the little specimens we bond with are being created with a little controlled injection molded piece, so everyone who does this test can get exactly the same results.
And it's really important for the exact reason you just said there, reproducing the results, right? If you use stone and it cracks and whatnot, you do all the testing, same size. I saw you put this together, how the tooth is sticking out and where you put the composite button. You do it the same with all of them.
Exactly the same. So everybody gets the same treatment. In that way, we can make sure if you do something different in your test, you over thin or you leave it too wet or you do something different, we aren't questioning, was that the tooth or was that my technique? We get pretty darn close to saying it's the technique we're now testing rather than other artifacts in the test.
And then if you can get a little closer, I'm going to show this again. So right here, there is a composite button right there.
Well, let's actually take this as a different route. This is the whole human tooth one.
Oh, wait, so this is a Denton one.
That is Denton.
So we're going to actually test this so we can get the reading for Denton first, and then we can compare everything else.
Yeah.
Well, let's do that. Neil.
So let's talk about, for 1 second, why that's so important.
Yeah.
Because every one of you guys have heard of megapascals over and over and over, but it doesn't kind of really mean anything. So if I take a whole human tooth and I put that in a lathe and I cut that back, leaving just this little button of Denton, and we break that off, now we have a bar set to say, here's how strong the tooth was. Now what kind of number are we shooting for? Rather than, well, people have told me 20 is good enough, or 30 is good enough. Let's find out.
Let's find out what it is for Denton.
Yeah, let's do that. So the setup here is we've got a little base clamp that we call this, and we simply put the specimen in we were just talking about. We put that in here and lock it down. And so now we get this very rigid, this firm mounted specimen in there. That's what we're going to test.
Yeah, it's not going to move around or anything.
We also have this precise fitting, what we call a crosshead, sitting here, and that crosshead is on this sliding mount, and that crosshead fits this thing perfectly. So I'm going to go ahead and set that in there. I need to put my glasses on.
We're going to put our safety glasses on there.
Okay, so that's in there, and I've just kind of leveled it up. Now we're going to go ahead and slide that into this machine. I'm going to put it up to where it'll fit in. Now it's just fitting in. And when I hit the down button over here, we're going to start capturing a load in here. And so as soon as I hit go, within a few seconds, it'll start applying a load. This thing is now forcing downward, and that is the load that's registering. So this machine can go to 100 pounds. This is kind of a smaller version of an Instron that these guys make.
And just to let everyone know, this is Denton right now.
This is Denton breaking from Denton. This is not a restored tooth. And so this sets the bar. This is in pounds. What you're seeing is pounds loading onto that. In this case, it reached 73 pounds.
73 pounds.
Yesterday you saw a different number. What did you see?
We saw, I think it was
96 pounds.
Yeah, it was a lot more.
Yeah, so 96 pounds, 73 pounds. Human dentin has some variability. So we're in the range. And actually, I'm glad we had this opportunity to see kind of the lower side. Oh, yeah. And this is actually way on the lower side of where dentin fails. And where you're at yesterday was on the higher side. But
so now you have something to shoot for whenever you're testing bonding and whatnot. Actual dentin.
Yeah, yeah. And so I think this is the place we should start out at. So in this test setup, that is megapascals as well. You can't say that if I load 70 pounds on something that it's 70 MPa, unless the size is right, because a big button, 70 pounds isn't very strong. A little teeny button, 70 pounds is really strong. And so we've got this ratio worked out. So for the first time, your followers can see, oh my gosh, the tooth is 73 megapascals. Yesterday it was 96. Somewhere between 70 and 100, that's about where we always fall. Yeah. So then if we break this off and we're talking, well, if I bond something on there, am I okay with 20 or 30 pounds, 20 or 30 megapascals to hold that up? I would have to bet everyone would say no way.
You would say no, because we just saw that for dentin it's 73 right here. This is on the lower side.
This is on the lower side.
And we want to strive to get as close as we can.
Yeah, absolutely.
So Ben, you've seen a bunch of these. Does this get old to you whenever you see these experiments here?
Just as exciting every time.
So let's look at some of the specimens that we did the other day and let's test that.
Do you want to do that, or do you want to see an immediate, or how do you want to start?
Well, let's do this.
So the 24-hour.
So what we'll do is we'll do a. Let's do the 24-hour.
Okay.
Let's do the 24-hour.
So, Glenn, you did this magic.
I did. I actually did this myself here.
I'm making a noise in the background with our oven, our easy bake oven. Here. Okay. So, on this one, this was Glenn's own hands, and we were bonding with a brand new box of Clearfill S3.
So right here, guys, I use this bonding agent right here.
And so this is kind of an interesting exercise. Your own hands, you get to see what they stack up to. And so there isn't any real magic here.
It's the peak in there.
The peak's in there, so we can pull it out as well.
Okay, so we'll do the Clearfill first. Test this.
Are you nervous?
What's that?
Nervous to see how you did?
You know what? I followed the instructions, so hopefully, but I'm actually looking forward to seeing how it matches up. And here's the thing, we were talking yesterday, and you do these. I mean, how many of these models do you go through a day? Normally?
Yeah, in a regular day, our guys are going to do 50 or 60 easily. Some busy days, they're going to go to 100, but in really busy days, they'll do 150. In a crazy day, I've once done 280.
280. But average 50, 60. Now, why is that important? Just let everyone know here. Why is that important for you to just continually work on this and testing it?
So when we see a number like this, and we know that that's how strong the human tooth is, our goals have always been, how do we get an adhesive to do that? Because anything less than that is actually not holding up to what nature gave us. Yeah. We've got to try to get back there. You can't imagine that a 40 under that cyclic loading and fatigue is going to hold up. It just won't. And so this becomes extremely important to us.
And guys, what ends up happening is you get patients with sensitivity. You get patients with failed restorations. So these guys you are committed to trying to get to that number as close as possible. And that's why you go through, I saw in the fridge, you have, I think, at least 10 jars of teeth.
Yeah.
I mean,
thousands and thousands.
And for those of you who are Ultradent customers, there is a special program. Donate some teeth, and you guys.
It's called our Tooth Fairy program.
Tooth Fairy program. Just a little shout out for those who are Ultradent.
Yeah, they get money back on product.
There you go. So to help their research here. All right, so I'm looking forward. Let's take a look.
Ben, what we've got here is now a bonded specimen. That is a piece of Z100 Composite bonded right to the tooth. And this is actually Dr. Bo's own hands. Okay. And so we're going to go ahead and tighten it down.
No critiques, guys, on that composite, okay? It's for experiment.
Yeah, the Z100 is a laboratory grade composite for us. It is definitely not an aesthetic product. Even 3M doesn't really count it as that. It's even these days sold very little in the US. So we're going to do the same thing. We're going to go ahead and slide that specimen under there. It's now in the notch. It's just fitting perfectly. We're going to move this thing back into space, raise that till that slides under. And the machine, again, is traveling 1 millimeter per minute downward. When I hit the go button, it'll clear the 73 we have there. So all of you guys who are watching, you're going to remember that 73. This is Clearfill S3.
close in on that number.
And so you never know what you're going to get in this kind of test, and
So it's at 31.
31. So
and guys, you remember what Denton was? It was 73.
yeah. So 31. Would you be okay restoring a tooth back to that?
I don't know. Would you guys be okay when Denton is 73 and what we got for Clearfield was 31? I mean, I wouldn't.
It's not really a restoration if you're not getting it back to where it was.
Yeah,
right?
you're right. You're not restoring it. That's a good point, Ben.
So let's do this. Let's just say that you just pulled a bad batch out. So let's use another one. We did 7 of them.
Yep, you're right. This is as random as it gets, and this is live.
Yeah.
It could go higher, it could go lower.
So we're going to grab another Clearfield. We did 7. And when you do your experiments, that's why you want to do it. You want to have as many specimens as possible.
You can never rely on one number. And the fact is, we usually do sets of 7, and sometimes sets of 10, sometimes sets of 15. It just depends on what we're trying to, how much resolution we're trying to get out of the test to see.
So now let me ask you this: who is your contemporary with Clearfield? Is there someone there doing also tests over there as well, or do you know who that person is?
Every company has somebody or some number of people who are doing their bond testing for them. I'm familiar with many of them from many of the companies.
And do they do the level of testing? I mean, obviously you go through like 60 a day on average, sometimes up to 200.
I can honestly say no other company has gone to this level of effort, and I know that, and there's a reason I know that. We've created all the whole setup, and year in and year out, I've done this, and I've done over 50,000 bonds in my own hands. That's my own hands, and now we've got a lot of other testers. We've done probably over 100,000 with all of the other guys. 100,000 bonds to help you get it right. And you know, the magic is people think that, well, you can come in and do a test and kind of get answers. You've got to prove out that it lasts for 8 years, 10 years, 15 years. You've got to prove out that everybody can do it, that it's not one magic set of hands. So we do this like overkill to make sure that this always works.
And you also do it, you also test doing it the right way, and you also test doing it the wrong way.
Intentionally, yeah.
Intentionally, just to show what happens for those docs out there when you don't read those instructions, what happens.
Yeah.
So let's test it. I'm
Let's go ahead and you go. Okay, so number 2. And you know, a 30 is what I think probably pretty good for this product. It's where it should be coming in at.
27.
So you now are seeing pretty consistent. I'm 4 pounds away from the other bond. That's really tight from this. And if we continue, and if we want, we can do another one and then do a series of the peaks if you like.
Well, let's go ahead and go to Peak. I
Okay.
think you guys know about Clearfield here. And not just picking on Clearfield, but actually we had a bunch of other bonds. Neil asked if I wanted to do that, but we would have been here all night. So we only picked Clearfield. But Neil, you normally test all the competitors.
Yeah, we've tested every competitor that's ever been on the market. You know, if it's been out only for a month or so, sometimes we haven't got it in. But we're pretty vigilant on getting products in early and testing and finding out how the competitors are doing. We've been fortunate to know that we've always competed exceptionally well, and more than just, you know, 27, 30 kind of numbers. We're trying to get back to the strength of Denton, and I don't think most other companies are really truly understanding. The bar is at least 70, at least 70. So let's see what we've got with Peak. Again, your hands. Every time I do this, I kind of get a little bit of nerves.
And this is actually what we use here if you want to zoom in on that. So we use the Peak bond.
So right Selfetch with the Peak bond then.
Right.
Okay.
So literally every time I do this test, I get nerves because we just don't know what's going to happen. We've got, again, Clearfield and we've got Peak. And so we'll go ahead and hit start, see what happens here. When it's live, you don't know what you're going to get. So I always am nervous, have to admit. I've done it a lot of times and I've seen what can happen.
So we're at 57.
A lot stronger approach to trying to get back to that 70 bar that we kind of set.
And that's the bar. The bar is the 73. Yeah. But if you guys remember what Clearfield had, I think it was 30 and 27.
27 and 31 or whatever
31,
it was.
yeah.
So we're going to do another one, right? And there's a reason why we do multiple, because sometimes you can't just rely on that one specimen. You got to look at other ones as well.
So again, completely random, and it is kind of our hands, our work on the line, and we should feel a little bit of nerves, like, are we getting it right?
And this actually wasn't Neil putting the composite on, it was me. I came in, he just told me to do that, and I just did it. So obviously Neil's been doing it for a long time. He probably knows how to work this. I came in and literally just started doing it. So this is off my hands here.
Yeah, yep. Okay, and that's where, again, there are learning curves. Yesterday we learned about film thickness. When you blow it, how thin it should go. And there are always nuances to this test. But what we're trying to get is a user-friendly product that consistently outdoes the other products. So,
61.
first time you've ever used this product as this way.
First
in this
time,
way.
yeah.
And so you're seeing a vast difference. You're actually seeing double, twice the bond strength here that you just saw off of Clearfill S3. And we could go through all the rest of them and probably find some that are getting close to 70, some that might get a little bit less.
So let's talk about this, because with Clearfill, it's an all-in-one. And I was just telling you, I was like, that does not seem right. Everything's there. What we used was Peak, and if you can go over this real quick.
Sure.
We used the Peak bond, and then we also used
the self-etch part of that. And so we have an acid component that is actually held separate in our system. In fact, if we talk about, sorry, I'm going to reach across the camera here again. So when we've got an all-in-one, we're really trying to get all the chemistry handled and managed there. That means etching the tooth and laying down an impermeable enough membrane to be a good hybrid layer.
all in one bottle.
All in one bottle. And so we've never been of that philosophy, and it doesn't mean that we will never arrive. I've learned a long time ago we should never say never. But where we are presently is we've even held the acid separate from the resin. And so when you got this yesterday, you took a hold of this end and pushed this in there and cracked it in. That meant this product was fresh, and it was going to be able to give you values like this without question. So when we activated that, then we've got this syringe ready for 3 months. Now you're operating directly in the mouth. You're not dispensing and making a mess that way. After you've etched, you've opened up the tubules. Everybody's talking about self-etch from control of sensitivity because you maybe don't disrupt the smear layer. Well, if you're bonding to the smear layer, you're bonding to the soft stuff. You aren't bonding to that strong mineralized
the tooth structure.
That's it. And so we're trying to get into that, open that up, and then leave something behind that is really favorable for this to go in. So this is now our monomer system that goes in, penetrates, and locks. When we light cure it, it locks in. Like Grim Death there, 61 pounds.
Yeah.
61 pounds on that tiny button.
And yesterday we were talking about just being, you even test how much you want to dispense it, how thin you want to get it. And so I really want to just kind of show that really quick. So
yeah,
let's do that real quick. Let's put the, I think you did it on the mirror, right? You put the bond on the mirror, and then from there, because it's all about being able to use it the right way, right?
Yeah,
I mean, because user error will cause a lot of discrepancy. Ultradent is really big on that. So
here's the glass slab. Would you like me to do it?
Yeah,
just demonstrate. Okay, Ben, you're going to kind of get in here close.
Okay.
And what I'm going to do is just clean off this glass slab. And I'm going to thin this adhesive out to be something like you would experience clinically. So first off, I am always going to start, even clinically, with a puddled coat. We would have scrubbed that around onto that etched dent. And again, this is the adhesive component. We would have already etched the tooth. I would scrub that around. Once I had that scrubbed in and it had penetrated into the tooth, we now need to thin that to the right level. And so I would take my air syringe, and you guys are going to have such a large amount if you do it this way that you're going to feel like it's kind of messy. And so what you want to do is take your high volume suction and kind of get rid of the excess, suction off the excess. But then take your air syringe, see if I can blow this in, and then start pressing.
And you just want a very thin layer. You don't want it pulled in there.
And I've kept the air on there for about 10 seconds to pull off all the alcohol. So I'm going to show you how thin this really is just a second. So I'm going to go ahead and light cure. And then I'm going to take that off this glass slide with a razor blade. The reason for that is I want you to see how thin this adhesive actually is, because there's a lot of belief that maybe multiple layers of adhesives is the right way to go. So I'm just going to wipe off the inhibition layer, the sticky outside, which is what your composite hooks to, and I'm going to take the razor blade. I've got one here.
We used it yesterday.
Yeah, it's sitting right here.
Underneath something.
I apologize, guys, for this. I've got one.
Here, it's right here, Neil.
Oh, you've got it. Okay.
So why is it important? So look, Ultradent here. The reason why I had Neil do this is that I wanted to show you guys they test everything. You test all the different bonds. Test it when you're doing it right, when you're doing it wrong. they're even testing it to how thin they want you to get that layer. So check that out.
So that's that center space right here where we would bond. So all that would have been suctioned off with your high volume suction. I don't know if it's showing up on camera well, Ben.
Yeah, if you can put it maybe on this, then
Okay, let's do
just
that.
for the background.
But that center area is as thin as saran wrap there. It's not thinner than saran wrap. It's not thicker than saran wrap. It's as thin as saran wrap. And so the area that we would actually bond to is really just more than paper thin. It's saran wrap thin. That surface, as I reflect that back at you, you can kind of see is the bonding surface we want for all adhesives. It doesn't matter if that's Peak. It doesn't matter if that's Clearfill SE. That's the adhesive we want left on all bonding surfaces. So that's ideally what any type of restorative should be, not multiple layers, unless it's too thin on the first layer. You're trying to get to saran wrap thin. So stretch a piece of saran wrap, take a glass slide, and push the adhesive and then slide off and see, does that equate to that? If you've got that, then you're there. That's really one of the main keys.
So guys, obviously you saw the commitment that Ultradent has to their bond and how they test it. I mean, even down to how thin they want you to apply it. So for those of you who are really interested in this, type in the comments section Ultradent, okay, and I'll talk to Neil and maybe we can work something out. We'll get a deal for you guys. But type in the comment section Ultradent. What we're gonna do is we're gonna shoot a different video in a second, and we're gonna talk about all the curing lights, because we know about all the curing lights. You guys are talking about eBay curing lights, comparing it to Velo lights, right? There's no comparison there. So stay tuned. We're going to shoot a different video. Watch that video, and we'll be back in a second. Thanks a lot, Neil.
Thanks, guys.
Thanks.